A confirmation for the audio, please. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. We shall be starting in a couple of moments. Mantle plume is temporary, then why it is said to be fixed? Okay. So basically, here the position is considered to be fixed. Okay. The position, that if in an area a mantle plume is in existence, it will be in that region, it will be restricted to that area is itself. But when we talk about the phenomena is temporary. Okay, so that means position, so once it comes into existence, it comes into existence, it stays in that region, only in that region, as long as the plume or the heat is provided. Okay, that is the aspect of the mantle plume. Okay, I hope that is clear, Annie. Abhishek, it's my humble request that whenever you do daily news analysis on YouTube, please take some queries after every topic. That is done in most of the cases, in most of the topics, it is done, Abhishek. Why, in certain cases, after 4 to 5 questions, we jump on to the next topic? Because please understand that analysis is not like your online classes, because of the many viewers who are present live, you have around 20, 30, 50 questions which are cropped up. Now, if, let's say, I assume that, or try to understand this, let's suppose you have asked a question, I have answered to your question. Now, general human tendency is that once your question is answered to, you want to move on to the next topic. So while we take up few of the other questions, majority of the viewers, they get impatient that please carry on with the next topic, we have busy life around us as well. And those whose queries are unanswered, they will always feel aggrieved. So that is always a kind of a give and take in the case of live sessions. Having said that, whenever if you have noted that whenever I take up the daily news analysis, I always ensure that after every topic where I feel that this is a topic which is difficult to understand, there can be various questions around it, I do take up the questions. However, I never take up the questions which are more, or never take up the suggestions in general, where the candidates, they provide the suggestions that this is something which could be done, this is something which can be done. Now, if you have understood a topic in a deeper manner, only then you will be able to provide suggestions. So there, the candidates, all they are seeking is a kind of a conformity, that what I'm trying to tell as a suggestion, confirm that it is a correct suggestion or not. So those kinds of things we tend to ignore because we have many questions to take up. So I hope you understand the entire predicament of it. Okay. So now we continue with the portion of volcanic hotspots. Now, volcanic hotspots, when you think about hotspots here, please understand that what do we understand by hotspots in general? Hotspots are those areas where any event occurs with a greater amount of frequency. That is what is considered to be a hotspot of a crime, right? Hotspot of an issue. So there you have any particular event which occurs with greater frequency. When we talk about volcanic hotspot, these are those areas where you have continuous volcanicity which continues or exists not only for hundreds, thousands years, sometimes even for many millions of years in general. Okay, so these are those volcanic area on earth that generally tend to lie above the mantle plume. As a result of that, here you will experience continuous volcanic activity for millions of years. That is volcanic hotspot. Here eruption will continue to happen. Now, in this situation, when we talk about a volcanic hotspot, here you have to understand that the magma chamber exists in the region of asthenosphere. So, being present over a region of mantle plume means that the magma chamber is continuously refilled. Now, being above or over a mantle plume, that signifies that magma chamber is continuously filled up. It is continuously filled up. So that is why you have a continuing volcanic activity. Now these hotspots, they end up creating a chain of landforms on the surface as a result of the plate movements. So this continuous volcanic activity means they create a chain of volcanic landforms. Okay? They end up creating a chain of volcanic landforms. Why and how? That is because as the magma chamber continues to supply the magma which leads to eruption, the plate above it continues to move because the plates continue to move. Creating a trail of eruptions, trail of volcanic eruptions. So for example, suppose let's assume that you have the presence of a particular landmass here, and here you have a kind of a magma chamber. Let's assume you have a magma chamber which is consistently being supplied with the help of a mantle plume. Right. Now you have a mantle plume which continuously ends up supplying that. Now in this situation, the mantle plume will keep on filling the magma chamber. Magma chamber will be filled continuously. Now here, let's say the eruption happens. Now when the eruption happens, it will lead to formation of a landform in this area. The eruption will create a landform in this area. Now, that landform will be subjected to movement as well. Right? Why? Because it is lying on the plate. So let's suppose if this is a plate and this plate is moving in this direction. So after, let's say, few thousands of years, as the plate movement is happening, what will you expect? You will have an expectation that this particular volcanic landform which was created here, that is associated with the surface, it will move somewhere here. Sometimes it might happen that it is still having a connect with the older magma chamber. That might lead to sporadic, irregular eruptions happening here also. Right? So sometimes that also might happen, that still volcanic eruption is happening. Otherwise, the main volcanic eruption will now happen here. Now, after some time, after few thousand years, again the plate will move. So after some time, what is it that you are going to experience? You are going to experience that this particular plate also ends up moving. So here, the earlier two landforms which were created, they would have moved now. And that would mean a newer eruption has taken place. So here, accordingly, you will always come across a scenario that you have a trail or a chain of landforms which are created, volcanic landforms which are created. Because observe here, this image also indicates that here you have a volcanic hotspot and here you have the magma chamber. So observe that initially the eruption would have happened here, when this particular portion would have lied directly above the magma chamber. That is when the eruption would have happened. Then it would have moved, then the eruption would have happened here. Then it would have again moved, causing an eruption here, here, and so on. So that is how, as the portion of the magma chamber that is fixated, that is fixed, the plate above it, that is moving. So when the plate lies here, eruption will be here. Then along with that erupted landform, the plate will move. Now eruption will happen here. Then again the plate will move. Now eruption will happen here. Now plate will move. Eruption will happen here. So based upon that trail of landform or that trail of volcanic evidence, we can get a clue about what has been the historical movement of this plate, of this landform, and what have been the historical activities created by any of these hotspots. Now, overall, across the planet, you have two very prominent hotspots. You have 3 to 4 of the hotspots which are in existence, one of them over the region of Aleutian Islands and so on. But the two very prominent hotspots that you will find, the prominent ones, example, one is in the case of Reunion Islands. Reunion Islands. Where is Reunion Island situated? It is situated in the region of Southern Indian Ocean. Southern Indian Ocean. And then the other is the Hawaiian Islands, which is situated where? In the Pacific Ocean. Okay. So, for example, if we take a look at the Hawaiian Islands, observe here, the mantle plume continues to supply the molten materials in the magma chamber in the region of the Hawaiian Islands. Now, here you will find that, observe, this is the portion of Hawaii where the eruption is being observed even today. Even today, you will find that frequently the Hawaiian eruptions, they are observed. Now, even this eruption which has happened, this has also happened because that particular place, let's name this place as A. That place at one point of time, A, would lie directly above this mantle plume and this volcanic hotspot. So that is where it has shifted. So just imagine, by looking at the trail of landforms, you can understand the direction of the movement that the plates have undertaken. So initially, if A would have lied here, that means initially the plates would have moved slightly to the north and then they would have moved to the west. That is what has created this chain of landforms. In the meanwhile, you will find many seamounts which have been created. You have the Midway Islands, which had erupted around 27 million years ago. The Suiku Islands, which have been created or erupted around 65 million years ago. So that tells you that this volcanic hotspot has been in activity for millions of years. So here observe the older ones, right? The older ones, they have erupted 2.6 million years ago, 5.1 million years ago, 1.8, and presently this is the eruption that we are observing over the region of Hawaii. Similar is the case when we talk about the southern Indian Ocean as well. When you talk about the southern Indian Ocean, there, let us assume the southern Indian Ocean. Now here, you would observe this particular place. This is your Reunion Island hotspot in general. Now, it is again supplied by the mantle plume. Now here, at one point of time, even the Indian plate was lying over this. The western part of Indian plate was lying over this particular portion. That is when it erupted significantly and with greater frequency for the next few hundreds of years, the next few thousands of years and millions of years. That is where the entire region of the Deccan Plateau that was created. But since that point of time, after Indian plate left that region, Indian plate did not experience the volcanism due to this Reunion Island. But instead, you'll find the chain of various different volcanic landforms which have been created as a result of this Reunion Island. So this is again a kind of a volcanic hotspot. Okay. This is again a kind of a volcanic hotspot. So these are your examples of volcanic hotspots which are directly supplied by the mantle plume itself. Okay. So that is the impact of mantle plumes overall. So if you find a question about talking about and asking you that what are the impacts of mantle plume, the answer will be straightforward, that mantle plumes, first of all, you have to talk about what do we mean, what do we understand by mantle plumes, and secondly, you have to elaborate about the fact that these mantle plumes, they end up creating hotspot volcanism. They can lead to upliftment of the land masses. They can create tectonic activities and tectonic movement as well. They can lead to convergence, divergence, and transform movement of the plates. So all those factors, they are relevant, and the convection current allows the heat transfer from inside. So all these factors you have to write about when you have a question asking you about the mantle plume in general. Now we come to the intrusive volcanic landform. Intrusive means something which is present in the interior. That is what is considered to be intrusive. Now, intrusive volcanic landforms, what are those? So, we have talked about the fact that when we have a magma chamber, when let's say you have the presence of a magma chamber, now that magma chamber does require the pressure and the presence of gas to carry it up and to be able to break through the surface and come out and emerge as lava. What if there is not enough pressure? In that case, what happens? Or let's suppose the surface, the crustal layer is very, very thick, and crustal layer does not have any weak points through which it can break through. Then what happens? The molten materials, many of the times, it will solidify here itself. It will start losing temperature, losing heat, it will solidify there itself. Now, this process of solidification, will it be a slow process or will it be a very fast process? What do you think? This process in which it gets solidifies, will it be a slow process or a fast process? Very good. It will be a very slow process because it is present in the interior. It will lose heat very slowly, so it will be a very slow process. Sometimes it is also observed that, let's suppose we talk about this particular magma chamber, and here this magma chamber, let's say, this is your magma chamber. let's assume. And this is your crust, which is very, very hard. Now, in that situation, molten materials, if they have some pressure, they will try to rise up. They will find the various layers of the rocks, various different layers. Now they will start spreading in between the rock layers. Wherever they will find space, they will start spreading there. Right? And by that time, they will lose all the energy or the heat and they will start solidifying. So when they start solidifying, they would again be solidifying at different rates, at different particular shapes and sizes. So that is these landforms. How do we come to know that these are the landforms created in the interior? Over a passage of time, when the above layers are eroded, when the top layers are eroded, right, or weathered, then these portions, they are exposed. And that is how we get to know about them. Okay, so these intrusive volcanic landforms, they are exposed when the overlying regions overlying layers are weathered or eroded. Right? So then you have these particular layers which are exposed, and we get to know that, okay, these igneous rocks which have been created, which have been created or formed as a result of the cooling down of magma in the interior region itself. Now here, basically, lava that is discharged during the volcanic eruptions on cooling develops into igneous rocks. We do know that. Now, the cooling may take place either on arriving on the surface or also while the magma is still in the crustal portion in the inside. According to the location of the cooling of lava, igneous rocks are classified as plutonic and volcanic. Plutonic, the ones which are formed in the interior, they are referred to as the plutonic rocks. So these are the intrusive rocks. Intrusive rocks. Now, these intrusive landforms, they are basically classified into different categories depending upon the shape, the size, and where and when they have cooled down. So they are classified based on the shape and size that they exhibit while cooling down. Okay. So as per that, how they have cooled down, sometimes it can also happen that the entirety of magma chamber in itself will cool down. So it will give you a kind of a very large dome-shaped structure, right? Only after the top portion has been eroded, only then you will get a kind of a large dome-shaped structure. So that is where the magma chamber has cooled down. Sometimes they would be spreading in between the rocky layers. And rocky layers, they are not always going to be straight. The rocky layers are going to have a kind of a anticline, a kind of a syncline, a wavy format. So if they cool down in between them, they will also develop a wavy pattern. So that is what we have as facholiths. So accordingly, you have various associated names. Mayank, how Maldives, being coral islands, survived having that volcanic activities near them? I'll give you a different perspective to think about it. Think about a situation where volcanic activities created underwater or sea mounts. Those sea mounts being closer to the surface, now after the volcanic activity stopped, these were passive regions. And then slowly and steadily, the corals, they started inhabiting them. The corals, their height increased and they formed the coral islands. Do you think that can be a possibility, Mayank? Let me know if you think that can be the situation, if you think that can be the possibility. That initially you would have had the creation of a seamount. On that, coral habitation would have created these coral islands. So that is the situation which is observed even in the case of Lakshadweep, even in the case of Maldives. So it is not that corals have been present there and after that volcanism happened, but the other way around. Okay? Now, here we take a look at the various different intrusive landforms. This is relevant only for your prelims. I understand many of us have a target only of prelims, but ideally I would want you to target the mains examination. This is relevant for your prelims portion. Okay? For your prelims portion, you can have these different types of landforms which can be asked. So here, let us take a look at these different landforms. For example, batholiths. So batholiths are created when the entirety of the magma chamber solidifies. When this entirety of magma chamber that you come across, if that solidifies in the entirety of the portion, that is what is batholith. Now observe here that basically the molten material tries to come out in various different types. Observe, they have provided a kind of a bulge here. They tried to come out, but these rocks, they did not allow it to come out, right? So that creates a kind of an intrusive landform. We will talk about it in Indian geography also. But this is something which has also happened in the case of western part of India. In the peninsular part of India, I hope we are aware that general slope of the land in the peninsula is from west to east, where near the western Ghats the height is greater, and in India near the eastern Ghats the height is lesser. That is why majority of the peninsular rivers, they originate close to the western coastline and they drain into this Bay of Bengal in the east. Why do you think that height change happened? That height change happened in the last phases when India was still above the region of Reunion Islands. While India was above the region of Reunion Islands, you had a fluidic eruption. That fluidic eruption spread in layers across very large distances. And that is how you had the creation of a kind of a layered structure. And that is why it is also referred to as Deccan traps, derived from the term trepen, which means stairs. So there you had the fluidic magma or fluidic lava which spread. In many areas, the spread, the thickness of the lava spanned across a couple of kilometers even. So for the new eruption to happen, it was not easy to break the rocks. It was almost impossible to break through those igneous rocks, hardened and solidified igneous rocks. So that is when in the last phase, as Indian plate was moving over the Reunion Islands, there was this final push of the molten materials which happened. It could not break through the surface, but it solidified therein, and that is what provided the upward push to the western region. And that is why the western portion has got a greater height as compared to the eastern part in southern India. We'll repeat this, revise this again in the portion when we come to Indian geography and the formation of various parts of the country. There we will analyze it again, but this is just to give you an idea about it. Would solidification of magma chamber lead to a dormant volcano? If the entire magma chamber is solidified, there will be no eruption thereafter, Dolly. Okay, so batholiths are the cooled portion of the magma chamber. It is a large body of magmatic material that cools in the deeper depth of the crust, molds in the form of large domes. They appear on the surface only after the denudation process. Denudation is a combination of erosion and weathering. They eliminate the overlying materials, only then are these regions exposed. Okay, this is the example of a large batholith region. Okay, this entire area that you see, imagine that at one point of time, this would have been under the ground surface, significantly under the ground surface. And due to upliftment of the landmass and the removal of the top layers, that is when this is exposed. Okay, this would have been a part of the old magma chamber in the interior of the planet. Now, then we have laccoliths. Laccoliths are dome-like structures. It has got a pipe which connects it to the old magma chamber. It is no longer active. All these intrusive landforms which are solidified, there is no question of them being active ever again, because they have lost the energy, they have solidified, and if you have solidified materials, why will they come out on the surface? So same is the case with laccoliths in general, if you observe. Now these are large dome-shaped intrusive bodies with a level base, and they are linked with a pipe-like channel from below. This pipe-like channel from below, it connects it to the magma chamber. So this pipe-like channel connects it to the old magma chamber. Okay, so here observe the shape of these laccoliths. The shape of these laccoliths is like a dome-like structure. They have not been able to come through the surface or break through the surface because of the fact that the surface is very, very hard in this region. So that is why they have not been able to come to that surface in that area. Now here, once the topmost portion is removed and eroded, this is what you have as a resultant. So this is your laccolith. So if you have to talk about the shape, flat base, having a conduit connecting it to the magma chamber, and then the topmost bulge like this. That is a laccolith. And then we also have what is referred to as a lopolith. So when we talk about lopolith, it is a kind of a solid rock form with a flat top. In this case, what did you have? You had a flat bottom. Here you have a flat top and a shallow convex base associated that may have feeder-like dike or a pipe below. Now that feeder-like pipe or dike would connect it to the ancient magma chamber. Ancient magma chamber. Okay, so this is basically having a shape somewhat like this. Flat top. Now, when will you experience this? When you have significant amount of overlying rock materials which won't even budge, which won't even swell up as a result of that. That is when you will observe or experience the creation of a lopolith. Okay, lopolith, laccolith, phacolith, all of these, sills, dikes, batholiths, all of these are formed or are an outcome of the same process. The only difference is that the shape that they take in when they cool down. That is the only difference which differentiates all of them in general. Okay, so that is a lopolith. Then you have a phacolith. Phacolith is what? In this, generally when we talk about, let's say, any particular rock bed, sometimes the rock beds, they are straightforward and linear as well, but sometimes you will observe that the rock beds, they are compressed in a way and they have a kind of a shape associated like this, right? So if the rock bed is like this, let's suppose, and the molten materials they get in between the rock beds, they will also solidify accordingly. So generally, under normal conditions, you will observe that the rock beds under normal conditions are somewhat like this. But then, due to compressional forces, what is created is something very unique. You have the creation of a rock bed which is somewhat like this. Okay. Now, this upraised portion is what is referred to as an anticline. And this downward portion, depressed portion, That is what is also referred to as a syncline. So the molten materials, when they spread in this area or in this area, they will solidify according to that shape, a convex concave shape associated. So it is a wavy mass of intrusive rocks found at the base of synclines, or at the top of anticlines in general. Now here these wavy materials have a definite outlet to source beneath. So generally what you will observe, if this is the surface, let's suppose this is the magma chamber, right? Here you have the presence of these rock beds which have been compressed. Now the molten materials would have exited in this area, and the molten materials would have solidified here or across a syncline. So this solidification is what is referred to as phacolith. Okay, so laccolith, lopolith, and phacolith. Then we have the easier ones, sills and dikes. Now, when we talk about sills, in this situation, in the case of sills, what do we come across is the fact that here the solidification takes place significantly between the parallel rock beds. So rock beds are very parallel to each other, right? The rock beds in this case, they are not wavy or compressed. They are very parallel to each other. And when it spreads in between them, that is what forms sills and sheets. How do we differentiate what is a sheet, what is a sill? So when you have the deposition in between the layers to be very thick, that is a sill. When it happens in a very thin manner, it is a sheet. So near horizontal bodies of intrusive igneous rocks, they are referred to as sills. And the thick horizontal deposits are sills, whereas the thinner ones, they are referred to as sheets. Here, take the look at this image. Observe this particular portion. Observe this portion that you have. Right? Now the rock beds, they are linear, and this is the example of a sill. This is your intrusive igneous landform. Intrusive igneous landform. Okay? Now, if this would have been very thin, it would be referred to as a sheet. But if it is thick enough, that is what we consider as sills in general. Why they are parallel? Vivek, under normal circumstances, the rock beds, they are parallel over each other. That is how the creation happens in terms of even, let's say, the igneous rock formations due to volcanic eruption that happens, the deposits will always be parallel to each other. So under normal conditions, they will be parallel. It is only under certain conditions of compression, tension, etc., when that parallelity is actually impacted. So normalcy means parallel. That is how sedimentation also, when it happens, one layer upon the other layer upon the other layer, that is how even sedimentation happens. Then we have dikes. Dikes are basically vertical wall-like solidified portions of magma. So here, observe this. This is a kind of a dike. Okay. So wall-like formation of solid magma, oftentimes vertical. Now, these dikes, by the way, are very rich in mineral deposits. They are very rich in mineral deposits. Why? Because significant amount of pressure is there, and some of the minerals, when they move up, they will move up in chunk because of the density. Most of the minerals, they will move up in chunks, so you will be able to find larger concentration. In South Africa, you have many of these dikes which are very rich in kimberlite deposits. So for example, in South Africa, Many of these dikes are rich in kimberlite deposits. Kimberlite deposits. And from kimberlite, which particular mineral do you extract from kimberlite? Let me see. Any of us who are aware that which particular mineral is extracted from kimberlite? Without searching from Google, obviously. Okay. So this is where you'll find diamonds. Okay. Why are they rich in mineral deposits? Generally, all the intrusive landforms are rich in mineral deposits. In the case of dikes, you will find significant concentration of these minerals happening in a region because it is a narrow area. So it is easier to extract as well. And here you will find greater density in the small portion. That is why they are said to be rich in mineral deposits. Okay. Now, after this, we come to the chemical composition of the magma, which determines the eruption style, which determines the behavior of that magmatic material, and also determines the types of rocks which are formed as a result of solidification process. So magma types, we have seen that based on viscosity, they are classified into two categories. That is one which can flow easily, one which does not flow easily. And when we talk about something which flows easily, observe that, for example, in the region of Hawaii, this is the kind of eruption that takes place, which flows very easily. And this will create what kind of a landform? It will create dome-shaped or shield volcanoes. And here you will observe the formation of cinder cone in general. In this region, generally you will observe cinder cone. Generally. So this is viscosity is less. So less viscous. And it is highly viscous. So observe, it moves in chunks and blobs. And that is where a lot of gases are also erupted. So this is viscous. Okay. So broadly, based upon the chemical composition, magma is classified into mafic, and felsic. Now, when we talk about mafic, Ma here stands for magnesium, and Fic stands for iron. So here, this is going to be rich in iron and magnesium, whereas this is going to be rich in silica. So here, if you think about it, when we say mafic, it flows easily, so rich in iron and magnesium, less silica. Now, when we talk about silica, silica is very light, right? And that is where silica oftentimes is bright colored in terms of the pattern also. And even in molten form, it exists in various different blobs of shapes. And that is where it traps a lot of gases as well. So imagine if you have a kind of a material, molten material, let's say a blob of silica, it has got the presence of gas bubbles, a lot of gases are present. And on the other side, you have a magma which flows like this, and it does not have a lot of gas bubbles in it. Now, upon solidification, A will be denser or B will be denser upon solidification. What do you think? When these will solidify, A will be denser or B will be denser? Very good. Easy. B will always be denser. Density will be more. That is weight per volume. That will be more in the case of B. In the case of A, you have gas bubbles. So here, silica always you will find in molten form, it tends to form viscosity, and that is where it will start forming the gas bubbles within it. So that is why mafic will have higher density. Higher density. Okay. It will be darker in appearance due to the presence of iron and magnesium, darker in appearance upon cooling. In appearance. Now, even though I've asked it earlier, still I would ask you again. So, in this case of mafic eruption, do you think there will be an explosive eruption or a non-explosive eruption? What do you think will be the situation here? Explosive or non-explosive? Simple again. So here it will be non-explosive because it is fluidic. It can move very easily. So non-explosive. Whereas when we talk about the felsic magma is very poor in iron magnesium content, and this is something which is very rich in silica. So if it is very rich in silica, it is poorer, and feldspar also, correct. So it is very rich in silica and feldspar. So here, poor in iron and magnesium. Now, what can we say about the coloration of the magma in that case, coloration of the rock which is formed in this case? Will the color be brighter or will the color be darker? Good. It will be light colored because iron and magnesium, they give you that darkish appearance. So here it has got a lighter color. Upon solidification, lighter color upon solidification. Now here, what about the density? High or low? Density, what do you think? Is low. So rocks are lighter. Okay. Now here you will always have an explosive eruption. Explosive eruption. Now in this case, when you have this felsic magma, it will form a light substance upon cooling down. Now that light substance, do you think it will tend to sink to the bottom around the oceans, etc., or it will tend to accumulate? It will always tend to accumulate. It is very, very light. So that is where it tends to accumulate, and this leads to formation of those land masses. Whereas majority of the mafic magma you will find, they will be moving across, spreading across the ocean floors, and that is where they will form the oceanic crust, basaltic magma in general, basaltic rocks in general. So, but nonetheless, overall, anything which has got lighter, which has got lightweight, is light in density, it won't sink very easily. So it tends to, and it is viscous as well, so it tends to accumulate over each other, and that is how you have the creation of various land masses and landforms as well. That is why in majority of the areas, the soil that you have, the soil is rich in silica, very rich in silica. The sands that you see, any area, let's say in the coastal area or in any region, the sand that you come across, that consists of a lot of feldspar, a lot of silica. So Imagine how they would have been created. They would have been created initially, the entire planet was underwater. And imagine that situation when the entire planet has been underwater. So if I can just um, help you imagine that. So basically, imagine this. It is not going to be the perfect imagination, but I'm not a filmmaker for that matter. So here, let's suppose the entire region is underwater. Okay. Now, from here, you have eruption of mafic. Now, mafic will spread around. Mafic will spread around very easily. Let's suppose here you have the felsic. Felsic will start accumulating. Okay. Eventually, they will accumulate on top of each other. And that is how you have formation of these landforms. And these are very, very light in general, right? Whereas it is not as if this mafic cannot create landforms. They will also get accumulated. They will also eventually get accumulated. But very rarely will you find them to be the base of any kind of landform in general. Very rarely. Whereas this felsic will be the most frequent one that you observe. So just by knowing the characteristic of the magma, we can understand or we can predict the type of eruption that will happen. Now, this is a chart that you can use for your prelims purposes. So use this for your prelims. So here you will observe that based on the silica type, the amount and the quantity of silica which is to be found, here based on that you will observe that if the silica content is less, then it is mafic type, and here it will be non-explosive, because if the silica content is less in the mafic type, it will flow very easily. Then if the silica content, and here it will have low viscosity and hence low gas presence. If the silica content is very high, felsic, high viscosity, high gas content, and for this to come up, you need explosive eruption. Okay, apply this logic, you will be able to solve any kind of question that is asked from this area. Generally, the question will be asked only from your prelims perspective. Mains type of question for general studies, UPSC does not dare to ask the questions in general studies which requires you to study too much. Otherwise, the candidates, they know how to create a hue and cry that UPSC asked this question, that is why I could not become an IAS officer. Nobody asked me why the other 99 questions I could not solve. So only because of this question, I could not become an IAS officer. You will immediately come across a scenario where there will be a WhatsApp group created, multiple WhatsApp groups created, YouTube channels being launched on that. People will start giving dharna at the Jantar Mantar, and the easiest demand that they will ask is, give us one more attempt, right? And this has been the demand as long as I can remember. Think about it, that as long as I can remember, even ask your parents about it, as long as they can remember, you will always have a certain set of candidates who will always be having that demand for one extra attempt. Already, UPSC has given you 6 attempts to clear the examination, but you need one extra more attempt. So I hope none of us present here will have that kind of an excuse making in our life that I would have become an IAS officer if not for that question. Okay. Which NCRT is important for geography? The NCRTs of class 11th and 12th. That will be more than sufficient. You start with the physical geography of the world, and then after that you come to the Indian geography. So always advisable to read the physical portion of geography first and then come to the portion of Indian geography, because then understanding India is much easier. The other way around is much more difficult, that understanding India and then looking at understanding the basics of geomorphology, climatology, that is very, very difficult. Even though it is easier in terms of the teaching pedagogy, because all of us, we relate to India, right? Because if, let's say, I am talking about the global distribution of earthquake here, barely anybody will have an interest that what do I do if Mediterranean is experiencing earthquake? How will it change my life? But if I start discussion about the topic that when the Bhuj earthquake happened in Gujarat, these many people died, and this is where the government was changed, and that is when Narendra Modi was made the chief minister of Gujarat, and that is after that his rise happened. Everybody will have all the years spiked up. Even right now, just by hearing the name of the prime minister, many, okay, what is the controversial thing that he's going to say? So all of us are immediately very interested about these aspects of Indian geography. So always I would advise, finish the portion of physical geography, even though it might seem very cumbersome to start with, but it is always going to benefit you in the long run. Okay. And how newspaper good? Newspaper very good. Newspaper is something which is going to help you in, I hope we are all interested in improving our language skills as well. Language skills are very, very important. Whichever language you are following, whichever language you are speaking, not necessarily English, whichever language, let's say Hindi, let's say Kannada, let's say Tamil, let's say Malayalam, any particular language that we are speaking, using, we are going to communicate in, you should have a command of that particular language. So that is something which will be given by the newspaper. Ability to write, that also comes from reading. And that is where from our childhood days we have been taught in a certain scenario, and for which we are not to blame, but our teachers had taught us that write the notes that I will dictate, vomit that notes in the examination, then you will get very good marks. Never try to recreate an answer on your own. So writing skill has never been developed. How to recreate an answer, how to write something which is present in your mind in your own words, you'll find that is the most toughest thing. And that is what the candidates face as a problem in the mains exam. That is where majority of the candidates you will find at the end of the exam, when they come out of the exam hall, the most common concern will be, and the most common grievance will be, I knew the answer for this, I could not write it properly, so I will not get good marks. Why couldn't you write it properly? So that is where, for even improving, as Stephen King has said, that in order to write one page, you must at least read 1,000 pages. Then you will be able to recreate that one page. So get yourself exposed to as many reading materials. Okay. And Jafrina, can you tell me the first day topic of our session? First day topic, Jafrina, was basically about the very simple processes of the planet Earth. And we talked about the evolution of universe, the evolution of solar system, formation of the planet, Milankovitch cycles leading to the ice age, and so on, continental drift theory, the rock cycles, the interior structure, all these. Okay. Which newspaper is important for us? One newspaper, not newspapers. Unless and until you clear the mains examination, only one newspaper. And either, if you are appearing for English, either the Indian Express or the Hindu. Any of these newspapers, you should be sticking only to that. Okay, if you have got time, then always augment your information by some of the magazines like Down to Earth and so on. That will always be helpful. But one of these newspapers, and here again, all the candidates, they get FOMO. That is fear of missing out. That is, you start reading the Hindu, you find, or you get together, you discuss with all your peers, they will bombard you with a certain topic, they will ask you about it, and if you have a blank face, immediately they will have a broad smile on their faces. You know what, I'm reading Indian Express, that is why I know about this. You are reading Hindu, that is why you don't know. Don't get perturbed by this. This is the biggest trap that UPSC has during the preparation. Never get influenced by what the peers are throwing at you. Whichever newspaper you have started, stick to it, be regular throughout your preparation phase. Okay. And monthly magazines are sufficient. Yes, they are sufficient for your revision, not for the prime reading or the first reading. That is not at all sufficient. Monthly magazines only for revision. Whatever portion of current affairs you have studied, that has to be revised periodically, and that is where the role of monthly magazine comes in. and that is where the role ends as well, not beyond that. Okay. What about the new India Samachar magazine by government? It is good, but then see, you have many magazines already which is there. Current affairs magazine you will have, rely upon that. Yogendra, just out of curiosity, you are an engineer. I was an engineer. I'm not an engineer anymore. So I was at one point of time an engineer. That is correct. So here now we come to the distribution of volcanoes, the global distribution of volcanoes here. So when we talk about distribution of volcanoes across the world, volcanoes will occur only in certain places. Which are the places where the volcanoes will occur? They will be occurring in the region of the plate movements, so convergence of plates, convergence of plates. Which plates? Only oceanic plates. Divergence of plates, divergence of plates, and also across volcanic hotspots. Okay. It is only in these areas that you will come across the frequent volcanicity. So a question which is very likely to be asked in the mains examination is, elaborate and discuss about the distribution of volcanic eruption or volcanoes. So ideally, again, you have to draw a rough image, a rough diagram of the world map, and there you have to elaborate upon it, that what are the regions of Pacific Ring of Fire. You will find in the Mediterranean region also significant amount of volcanic eruption. Why is volcanic eruption happening there? What do you think is the reason for volcanic eruption happening there? Even though we have discussed it, but actually after the lunch period, after the lunch time, I do make it a point to ask the same things multiple times to check whether we are awake or not, because after lunch, that is the easiest thing to do, to fall asleep. So why is it that the Mediterranean region has got the volcanic eruption? What do you think is the reason behind that? Okay. Interesting answers have started flowing in. Okay. So divergence of plates. Okay. Right. Abhijit, Mayank, you are correct. Sakshi, you have just written plate. So I don't know what to make out of it. And convergence. Okay. Any more of us who want to try out why that region expects volcanic eruption? Okay. Very good. Now, this is like heartbreaking. It is like having gone through the entire, as it is famously said, having gone through the entire portion of Ramayana, and at the end of it, someone asks you that, did you mention the name of Ram somewhere? Okay, split of African plate. Okay. So split of African plate will have an impact in Mediterranean? Okay. Fair enough. So what happens in this case is basically here the African plate is moving, but the movement of African plate is not leading to the volcanic eruption. Here the Mediterranean sea floor, that is subducting underneath the Eurasian plate. That is why on the boundary region you have the volcanic eruption in the form of Vesuvius, Etna, Stromboli, volcano. All these basically happen because of the Mediterranean region closing in. Just like how the Tethyan sea floor closed in, that is something very similar happening in the region of Mediterranean as the African plate moves northwards. Is that clear now? I hope we are not confused about the divergence of the plates. Okay, how many of us we don't have an idea which plates are diverging, which plates are converging? Please be frank and open. In that case, we'll talk about it. Okay. Fair enough. So here, I will give you some idea. So we start with this particular portion. Now here, understand that when we talk about the Pacific plate, this particular portion and this particular portion are same. So I hope we don't get confused. Now Eurasian plate is like the elephant in the room. Very difficult to move and very difficult to have any grip about it. Eurasian plate, everything else is colliding with the Eurasian landmass. So here the Pacific plate is subducting underneath. So there is a kind of a convergence here. Okay. Now, here the Arabian plate, the minor Arabian plate, that is converging into the Eurasian plate. That is where you have the fold mountain systems getting created here. Then here on this side, at one point of time, North American and Eurasian plate had also collided. But now they are moving, drifting away from each other. They are drifting away from each other. So this is a point of divergence. Here again, this is a point of divergence. Okay? This is a point of divergence. It is these mid-oceanic ridges that you find in this area. That is why the Indian plate is further being pushed north. Indian plate is pushing into the Eurasian plate, and there's a convergence happening. Here, the oceanic crust of the Indian plate is subducting underneath the Sunda plate. Okay, that is why here you have the Sunda Trench, the Java Trench, and volcanic eruptions like Krakatau and so on. Here, when we talk about the Philippine plate, now the Pacific plate is subducting underneath the Philippine plate, and this is your minor plate that is oceanic, that is Caroline plate. So the Pacific plate is colliding with the Caroline and the Philippines plate, and the Pacific plate being the older and the heavier one, that is undergoing subduction. It is in this region again where that entire region experiences the subduction or a convergence of the Pacific plate. So Pacific plate is subducting in all these areas. This is a particular portion of the extended Australian plate. This is a part of your Australian plate. So Pacific plate is subducting here also. And that is what is creating the Tonga eruption in this area. Mount Pinatubo that I told you, that Mount Pinatubo is created here. Now, when we talk about the oceanic convergence, it creates very deep trenches. Here you have the very deep Mariana Trench, the deepest trench in the entirety of the world, having a depth of close to 11 kilometers below the sea surface. Here you have an oceanic continental convergence between the minor Amur plate, which is a part of the larger Eurasian plate itself. And here also you have the Japan Trench, the Kurile Trench, and you have eruptions in the form of Fujiyama, Mount Fuji. Now, furthermore, here you have the minor Nazca plate. So there is a convergence happening between South America and the Nazca plate. That is why Mount Cotopaxi, Mount Aconcagua, different volcanic eruptions, and the Andes. Here, the plate is diverging. Here you have the East Chilean rise, or the East Pacific rise as it is referred to. This is where the rate of divergence is the fastest in the world. So, East Pacific rise. Okay. Now, as this plate is diverging across the entire mid-Atlantic ridge, that means here you have divergence which is created. Now the divergence is not happening at the same rate across the entire region. So that is where here you will find a kind of a transform boundary being created. That leads to frequent volcanic eruptions as well. Now in this area, you have the small minor Caribbean plate. Now this Caribbean plate undergoes convergence in this area and some amount of transform movement. That is why this area is a hotbed of seismic activities. You would remember various different massive earthquakes in the region of Caribbean, for example, Haiti and so on. They have experienced significant amount of convergence. North American plate, as it is moving from the region of the drift or the mid-Atlantic uh, ridge. So North American plate in general is moving westward. As it is moving westward, it is climbing over the Pacific plate. So Pacific plate, even though it is moving like this, but North American plate is climbing over it. So there you have creation of fold mountains in this area and volcanic peaks. For example, Mount Hood, Mount Washington, Mount Rainier, Mount Shasta, Shastina, all of them are created in this area. It is in this area that you will find the youngest fold mountains of the world in the form of Cascade Ranges. They are the youngest fold mountains who have been formed very, very recently, around 2 million years back. Here you have a transform plate movement in between the Cocos plate and the North American plate, creating the San Andreas fault in this particular region. Okay? Is that understood now? By this, can we say size of Atlantic is increasing and Pacific is reducing? Absolutely, yes. Pacific Ocean have too much tsunami because of these geographical effects? Yes, because there will be underwater earthquakes. Only the Atlantic region around Antarctic plate, Australian plate, and Nazca plate is showing divergence. Yes, that is not only, that is a very large area. So yes, these are the areas. And there's a divergence being exhibited here also across the East African Rift Valley. Here also, what is the Nubian fault as it is referred to. So you have divergence being indicated in these areas also. Okay? Any of us who still have doubt in this, let me know. No? Good? Fair enough. So this you can reinforce by looking at the detailed map which we have provided earlier in the portion. Okay, in the previous module you have got the detailed map, so there also you can have a look into it. Okay, so this is where the divergence is happening. This is where you have the hotspot. This is where observe the Pacific Ring of Fire. This entire region is the Pacific Ring of Fire in that area. Okay, so here you have the eruption due to the mid-Atlantic ridge. It is very easy to observe these ridge lines and to draw these ridge lines, because when you take a look into the water body, the brighter areas that you come across, typically these will indicate some or the other ridge across which there is expansion which is happening. How many questions are required for what, Roshan? Questions are required for what? Are you framing questions on your own, or is there some other purpose behind it? Okay. Explain it up and see, when you're putting a question, think about it that I am very poor in understanding the portion, so elaborate it, simplify it slightly so that mere mortals like us can also understand your question. Okay, now we come to the folding and faulting. Now all this is a resultant, is an outcome of the endogenic forces themselves. The forces which are acting from the interior, they are able to create these various different folding and faulting. Now what do we mean when we talk about folding and faulting? So folding and faulting refers to the various different types or various different impacts that you have due to the endogenic forces. So this is the variation in the land that you have due to tensional and compressional forces. So tensional and compressional forces create folds and cracks of faults across the surface. Now these tensional and compressional forces, they are horizontal in nature, isn't it? So all these tensional and compressional forces, they can have some or the other influence. Does not necessarily mean that they will only create a crack or only create a kind of a fold. You have variety of different instances created by them. So when we talk about folding, a bend in the rock, that is the response of compressional force, that is what we refer to as folding. Now here, effect of the compressional stress, whenever you have a compressional force, let's say a compressional force acts. Now this is a particular landmass, as it is compressed from both sides. What do you observe to be happening in this region? It develops a kind of a fold, isn't it? So that fold is going to have an uprised portion and a downward portion as well. The uprised portion is what is referred to as anticline, and the downward portion is what is referred to as syncline. Okay, so uprised is, if this is a kind of a fold, this will always be your anticline and this will always be your syncline. Okay, now then the folding, it differentiates, or it is differentiated, it differs depending upon for how long the compressional force has been acting in a region, what is the impact of the compressional force, etc. So there are different types of folding. So for example, think about it. Let me give you an example here. Suppose this is a landmass. Initially from both sides, I am applying equal amount of force. Observe that the folding will be very symmetrical, very normal, very symmetrical. Symmetrical means it has got the same angle from both sides. Now, if I continue to press from one side, observe that the fold changes. Eventually, observe that the fold becomes almost horizontal, right? If I continue to fold, or if I continue to apply pressure beyond this point, what will happen? The rock in this portion won't be able to deform that much. So it is here that the rock will break away. So the folds, they are basically classified depending upon the type of forces and the type of folds that are indicated. So here we have symmetrical folds. Symmetrical means as simple as that, very similar on both sides. Asymmetrical, one side has got greater bend as compared to the other. Then you have recumbent, where the folding has increased to such a level that the fold has now become horizontal. Now, if the folding continues, if the pressure continues, it will break from here. And that is what is the nappy or the broken fold. So we'll take a look at this. This is a kind of a symmetrical fold, right? Observe, on top of the surface, it will not appear folded because the soil will be formed, normal growth of plants, etc. You will never come across a scenario that, okay, this is also folded. But observe the fold here. It is absolutely symmetrical. So in those areas where the forces of compression are quite uniform from both sides, that is where the symmetrical fold will be observed. Example, the Alpine Cordillera. In some portion of shivalics also, only in some portions, you will observe this creation of symmetrical fold also. Then, if the force increases, initially when you have the symmetrical, if the force increases, what happens? The symmetry goes out of the window, right? So that is when you have the formation of asymmetrical fold. Observe in this scenario the fold. It is not symmetrical anymore, right? So this is an asymmetrical fold. So it represents the variation in the compressional stress from either of the sides. When there is a kind of a variation, that is an asymmetrical. In many portions of Himalayas, you will come across asymmetrical in general. The Himalayas, you will come across a scenario where in general it is being pushed from one end. Let's say this is the end. Now this end is continuously pushing. Take this as the Indian side. It is continuously pushing from one side. So that is why in the case of the Himalayas, majorly you will come across a kind of a topography which is somewhat like this, where you have very steep side on the side of the Indian portion and a gentle northern slope. This is the asymmetrical fold. In the case of Himalayas, this is also what is referred to as hogback topography. Okay, that asymmetrical fold. Now, that is why in the region of Himalayas, as we will study in climatology later on, that this is why one of the faces, they will have the direct upward movement of the winds, lot of cloud formation, lot of rainfall, leading to a lot of landslides as well. Now, then we have the recumbent fold. Recumbent fold, basically, the axial plane becomes horizontal or near horizontal, and it is also referred to as the sleeping fold. That is what is observed. Recumbent fold, it becomes horizontal. This is also a result of the folding activity. But here, the fold has become horizontal. It is somewhat like this. Okay. Now, if further pressure is applied and further compression is applied, what will happen? It will break from here. This portion will break away. Okay, observe these rocks. Recumbent fold. Does not mean that your mountain will appear like that. On top of it, the mountain very well might have a kind of a structure like this. But due to compression, the rocks within that mountain might experience this kind of a shape. Now, if you extend that pressure, if you continue that pressure, this is the point from where breakage will happen. And then what happens? You will have this particular portion which simply slides over. Okay, so after that, it simply starts sliding over. So this is what is your broken fold. Broken fold. Okay, that is what is a broken fold. In that case, in many of the cases, in many of the situations, you will find that this portion which has now lost contact with the original portion of the fold, due to the forces applied, this will continue to slide over the remaining portion. Many of the times it manages to slide for many kilometers as well. So recumbent fold, you'll find in very old mountains which have experienced a lot of compression. So even in the case of Great Himalayas, you will experience the presence of recumbent fold. Then broken fold, observe the broken fold. So here, look at the fold structure like this and look at this. So this is where at one point of time it would have been like this. But then because of the immense amount of pressure applied, this has broken. Now what will happen? This will slide over the region. In this portion, there will be movement, there will be sliding over this particular area. Okay, so that is what is a nappy or a broken fold. In such folds, induced compressional stress surpasses the ductile characteristic of the rock. What is the ductile characteristic of the rock? Ductile means what? So malleability and ductility, they talk about the properties of the materials. When we say ductile, that is ability to stretch itself in a wire format without being broken. So ductile characteristic is something which is surpassed, means its ability to deform without being broken, that is stopped. So that is when it will break, right? That is when the folds will break. They will start sliding over each other. Now you have many broken folds which are present in the region of the Himalayan mountains. It is dotted with the broken folds significantly. Here in the case of the Himalayas, you also have the thrust faults. Thrust, again very similar here. Remember, we had studied about it yesterday, that in between all the ranges you have a kind of a crack which happens, and that is where you have a thrust fault. Due to extraordinary compression, you have the rocks not being able to deform anymore, and that is where you have the development of the cracks. All this is basically because of compressional activities. Now, if I take you back to the entire portion, observe in the initial stage, when the compressional force is very uniform, when the region is or the area is also younger, observe a kind of a synclinal. Slowly and steadily, as the compressional force increases, observe that the folding also becomes asymmetrical. It becomes very significantly asymmetrical till eventually, after a point of time, it surpasses the elastic limit of the rock in that region. It will break, and look at what it forms. It forms a thrust fault. Now here, as the compressional force will act, this will move over the fault plane. And when it will move over the fault plane, will that movement be smooth or will it be irregular? What do you think? When this portion will be moving over the fault plane, will that be a smooth movement or an irregular movement? Irregular movement. And that irregular movement will lead to what? Always seismic activities or earthquakes. That is why it frequently will lead to earthquake phenomena. Can we say when tension is more, it leads to fault? And when it is less, it leads to fold? No, absolutely not. Because you have compression, which creates folds, right? Tension rarely creates folds in general. So if you have a tension in a particular area, if you're pulling it out, then how will it form fold? It will never form fold. Okay. So now we come to faulting. Faulting basically is the break or the crack which develops. Now here, rock layers, they do not always respond to stress by folding. Rock near the surface are cooler and under less pressure. That is why they will break very easily. A sudden stress on these rocks may reach the rupture point, resulting in cracking and breaking of the rock structure. Now, the conditionalities. In case if there is breaking of rock without a relative displacement on either side, the rock has broken but no displacement on either side, that is the crack which is referred to as a joint. So if you have a rock layer which has cracked up, which has broken, but there is no movement on either side, that is a joint. When there's a relative movement between the rocks on either side, that is what is referred to as fault. When these will move, then this will be referred to as a fault. Just the mere occurrence of a crack does not mean it is a fault. And whenever there will be movement across a fault, it will lead to seismic activities or earthquakes will result as a process. When faulting occurs, the rocks on one side move relative to the rocks on the other side along the surface of the fault. That is what is this particular region across which the rocks are moving. This is what is also referred to as the fault plane. That is what we also refer to as the fault plane in general. Okay. Now you have different types of faults which are created. For example, we have the normal fault. Now in this situation, what happens? In that case, you have, let's suppose, it is a result of tensional force. So normal fault is a result from tensional stress. So for example, let's suppose we have a rock type. Now let's suppose there's a tensional force acting from both sides. This is the rock. There's a pulling action. There's a tensional force. As a result of that, what will happen? Slowly and steadily, if I pull it from both sides, what will happen? Slowly and steadily, it will start developing cracks. Here, the cracks will start to develop. It will deepen significantly as the tensional force continues to act. And there will be a complete joint which is formed. Now, if still it is being pulled apart, slowly, what will happen? It will lead to a situation where one portion simply slides down the other. One particular portion simply slides down the other. So that is where you have a kind of a sudden elevated area that you come across. It is not elevated in general, but here you will find it is a resultant of the other portion simply sliding down, right? So this is your fault plane across which the movement is happening. That is what is referred to as fault plane. Okay, and this produces a steeply inclined fault zone where the block slides down the fault plane due to gravity, creating a fault scarp. This is what is an escarpment. The sudden high elevation steep wall like feature, that is what is an escarpment. Example, in India, Western Ghats. Western Ghats in India, they are an escarpment. So some portion of that land mass, significant portion of that land mass has actually moved down. It has sunk. Presently, it is under the region of Arabian Sea. Right? So that is why Western Ghats, you will observe they appear like steep wall-like formations. That is a resultant of a kind of a normal fault in general. Okay? This is the normal fault created by tensional forces. Now, sometimes you also have a situation where depending upon the type of material, if the material is very, let's say, brittle, and brittle means break easily, and the forces are acting over a smaller area, if I apply compressional force in this, I will not break this up because I cannot afford to replace this. So whichever cheap pen that you have in your room, use that for this experimental purpose. So for example, I compress it from both ends with a significant amount of force here. Now, eventually, after a point of time, what will happen is it will develop a crack. If I continue to push, what happens? The crack deepens. I continue to push and the crack is completed. Then what happens? One portion will simply climb above the other, right? One portion will simply climb over the other. That is a reverse fault, because in this case, one portion is simply riding over the other. I can try it on paper, but the paper doesn't break easily, my dear friend. So that is why you need something which is brittle in nature. That is why I'm asking you to use the cheaper pens which break easily as well, the 2 rupees, 3 rupees pen. So that is your reverse fault. So in general, when we talk about the reverse fault, here, suppose this is the rocky area. Now here you have the compressional forces. Now these compressional forces, they are acting from both sides. So if the region, let's say, does not have the deforming ability, that it cannot deform itself, it will rather break rather than getting deformed. So here it will start developing some cracks. The cracks will deepen and eventually you will have the formation of a fault plane as well, right? This is a fault plane. Now, if I further continue to push, what will be the outcome? one portion will climb above the other. It will appear as if it is defying the gravity because the land is rising up. You will have a situation where one portion significantly rises above the other. Okay, the upward movement. And this is what is referred to as a reverse fault. Okay, so produced from the compressional stresses where the upper block slides over the incline of the fault plane in reverse of the sense of gravitational pull. That is what is reverse fault. Okay. Now, sometimes you can have a combination of two normal faults and you can have a combination of two reverse faults also. For example, let's assume that you have this as a larger material. Okay. And here you are applying the tensional force from both ends. So, rather than developing one crack, if it is a larger area and there's a tensional force, it can develop two cracks. And when you further continue to pull it out, what will happen to the central portion? The central portion, which is now supported on the sides, if the sides are pulled out, the central portion will simply subside. Right? Observe, the central portion will simply subside, creating a valley-like structure in between. That is what is referred to as a rift valley. Why rift valley? Created due to tension or a graben also. So produced when tensional stresses result in the subsidence of the block of rock, where you have development of two normal faults. Development of two normal faults leads to creation of a rift valley. Example, Damodar Valley, where in Chota Nagpur Plateau, in the region of Jharkhand and West Bengal, in the Chota Nagpur Plateau. Okay, that is basically the Damodar Valley. And then you have the Horst fault. Horst is the opposite of this, and it is a resultant of two reverse faults. So what happens in this case? In this case, let's suppose you carry out compression over a larger area. A larger area of rock is getting compressed from both sides. If, let's say, the rock is unable to be deformed, ideally, if it is able to be deformed, you can always find the formation of a fold in this case. But let's say the rock is unable to be deformed and the forces are not acting over a very large area. In that case, you will have development of two different cracks, which will start developing simultaneously. It is not as if one crack will be completed, only then I will initiate the formation of other crack. These are not UPSC candidates that only after this subject will I start other subject. Parallel development of cracks. So parallel development of two cracks means when you have significant amount of compression, the central portion eventually, due to that compression, it is thrown upwards. And that leads to creation of what is referred to as a Horst, or what is also referred to as a block mountain. Block mountain. Okay. Right. That is what leads to creation of a block mountain. So here you will observe the formation in such a way that, let's say, in general, here you have the creation of a Horst. Now, obviously, it will be eroded by wind action, river action, and so on. So you will have formation of these peak-like features, these individual peak-like features. And then again, you might have a Horst again. In between, you have a depressed valley-like feature, that is the graben. So here basically the example of this, you can take the case of the block mountains as Vindhyas, Vindhya ranges, Vosges in Europe. Okay, these are example of your the block mountains or horst. Overall, if you will observe that this is the region where you will observe, if you name this as the Vindhyas, here you will also have the Satpura, and then it is in between that in the Rift Valley you will observe the flow of river Narmada. That is why Narmada follows a kind of a straight path. Regardless of the fact that all the rivers are moving to the east, Narmada doesn't get FOMO feeling that I should also have gone to Bay of Bengal. It would have been better for my prestige. Everybody now mocks me that you are the only one going to Arabian Sea. Narmada doesn't get worried by it because the Vindhyas and Satpuras, due to the forces, they have created a kind of a rift valley which leads it directly into the Arabian Sea. That is why it ends up moving through a kind of a straight line path, having very little amount of erosion in the process. And the same case is with Tapi as well. So amongst all the major peninsular rivers, you will find all of them, they move towards the Arabians, they move towards the Bay of Bengal. Only Narmada and Tapi, they will be moving towards the Arabian Sea. Okay. Horst is just like we start to force paper from both sides, but paper can get folded, my dear friend. Take the case of the cheap pen that you have on your table side, and if you are one of those who never uses cheap pen, buy a cheap pen and then use it. So here, if you compress it from both sides, what will happen? Or a plastic ruler, even that is, can be broken easily. So if you force it on both sides, what will happen? Initially development of crack, then it will climb up and move over one another. By the way, if you get hurt doing this process, I am not responsible. I have put the images for the explanation, so please don't get hurt during doing this experiment later. Put the blame on me because that faculty had told me to do this. That is why I'm bleeding. I want this etc please, so I'm not responsible for that. Okay, so is that portion clear? Any doubts? Mega, so block mountains are created by faults. Yes, it is clear. Okay. Now we come to the final portion of geomorphology, that is erosional and depositional landforms. Till now, all the various forces that we have been looking at, those forces were acting from the interior. Those were the endogenic forces. Now, in this particular module, we shall be dealing with the exogenic forces, the forces which are acting from the outside. Wind movement, river movement, glacial movement, all the sea wave movement. That is something we shall be concentrating upon here. Before that, we'll take a break. How long a break do you need? Because we will be providing break at 5 p.m. as well. Good, Abhishek. So, break off. Okay, 10 minutes. Okay, so see you after 10 minutes, and that is when we will continue. A confirmation about the audio, please. Thank you. Uh, Nitin, as we are referring to rocks here, these are tectonic plates or rocks available in lithosphere in general. That is what is referred to in these cases. Okay. So now we continue from the portion of landforms, erosional depositional landforms. In this, basically, we shall be concentrating on the exogenic forces. Exogenic forces. Now, this is a particular portion for general studies. It is relevant only for your prelims. In majority of the questions that you will find to be appearing from this area, they will be prelims oriented. So, relevant for your prelims. Now, in prelims, what is required is basically the type of landform, whether it is erosional or depositional, and then the agent of nature creating that landform. Now here we will also be studying about mass wasting. For example, we will also be studying about the basics of landslides. So the questions which are asked from, let's say, the areas of landslides, they are more or less oriented towards the portion of Indian geography. That why is it that the Himalayas experience more landslides as compared to the Western Ghats? Which are the portions along the Himalayas which experience more landslides? So those are the portions very common in the portion of Indian geography, and also in disaster management you study it. So here we shall be having a brief introduction to those aspects about what is landslide, what is a creep, and so on, and that will be sufficient for here. This is a portion very relevant for the optional areas. All those of you who are preparing for the optional portion, this is a particular chapter from which many questions are asked for, but for general studies only, prelims oriented question. We'll take a look at the questions as well at the end of this chapter. Avni, what are the two hosts around River Tapi? So around River Tapi, you only have one host and one mountain formation or one block mountain formation in the form of Satpuras. And Tapi generally hugs the Satpura ranges and follows it all around. Okay. So the earth movement that we come across, that is a resultant, or any changes on the surface that we come across, that comes across as a resultant of either the endogenic forces or the exogenic forces. Till now, whatever we have studied till now, that comprises of the endogenic forces itself. Now, these endogenic forces, they can be further subclassified into sudden forces, that forces which act all of a sudden, and also the slow forces, right? The slow acting forces. Slow acting forces. Now, the sudden forces which act all of a sudden due to something happening in the interior, for example, earthquakes and volcanoes, they also bring about a change in the Earth's surface. But the slow acting forces, they can create the horizontal movement of the plates. They can create a region to slowly and steadily rise up. They can also create a scenario where a region slowly and steadily sinks down. So they can lead to creation of various different types of landforms. So when we talk about diastrophism or the diastrophic forces, diastrophism is the process of deformation that changes the Earth's surface. Very slow process. It produces many of the basic structures we see on the surface, such as plateaus, mountains, and folds in the crust. So they act in a horizontal fashion in most of the cases, and they create the various different changes on the surface. So many of the areas you will observe there's a plateau formation also, which is created due to the diastrophic forces, and many of the portions you have the creation of a fault line as they end up moving parallel to each other, tension, etc. That is a part of diastrophism. It is further subclassified into two categories: aperogenic and orogenic. Aperogenic talks about the vertical movement. So it talks about the vertical movement of the landmass, or let me write it down here itself. Very slow vertical movement of the landmass due to the forces acting in the interior. Forces acting in the interior. Okay? Very slow forces. So for example, let's suppose in a particular region, let us assume in a particular region, this is the landmass. Okay? And here, let's suppose this is the portion of lithosphere. Lithosphere, always be mindful of the fact, includes the crust and the solid upper portion of the mantle. That is the entire extent of lithosphere. Now, in the portion of mantle, sometimes you have the rising column of heat. Now, this rising column of heat, very slowly and steadily, that is slowly and steadily, for all of us, slow and steady has got a different meaning and connotation. So let me specify what do I mean by slow. Means the land rises, let's say, by 1 centimeter in 2 years or 4 centimeters in 10 years. That kind of a slow rise is something which is experienced. So very slowly the land in this portion starts getting elevated, starts getting pushed up. So this entire process of upliftment, that might take hundreds of years, if not thousands of years. So that is how slow it is. Meanwhile, also we have seen that in the portion of the mantle, we also have the convection current, which has got a downward action of the heat. As a part of the convection current, you have a downward motion. So when the heat is being, or when the materials are being pulled downwards, there is a convection current which is pulling everything downwards. Here also, you can have a situation where there is a creation of a depression in this area. Later on, it can be filled by water body, and you can have a water body or a sea created in that region as well. So that is how the aperogenic forces, they are also referred to as the continent building forces. They correlate to the vertical upliftment or subsidence of a large mass of land. Another portion of diastrophism is the orogenic force. Orogeny or orogenic. Whenever you come across this term, always associated with mountain building activity, mountain formation activity, mountainous activity, anything, that is what is orogeny. Even the rainfall which is induced due to the presence of mountains, that is orographic rainfall as it is referred to. So when we talk about orogenic forces, they are categorized into folding and faulting because of the compressional and tensional forces. So this is because of the compressional and tensional forces. Now here, I don't know how many of you have realized this, that we have covered different types and different categories of mountain formation as well. So if you are able to correlate and compile everything that we have studied, I hope we are aware that you have different kinds of mountains. All the mountains, they are not the same. So, okay, let me have this. Let me ask you from one of you. When we talk about mountain formation. Mountains. What are the different types of mountains that we have studied till now? Let me know. Okay, fold mountain, one of them. Example of that as well. Fold mountain, Himalayas. Can we give the example as Himalayas? Normal mountain is what? Fold mountain is also a normal mountain. Okay, very good. Other is block mountain. That is example Vindhyas. And then you have volcanic mountains. Beautiful. Okay. So like this, if you take a look at the examples of this as well across the world, trust me, you will be completing the entire portion of world geomorphology by this itself. Having said that, I would want to example of this. We can take Mount Aconcagua, Mount Cotopaxi. Having said that, I would want to give you some map pointing portions as well. Now, the purpose behind giving the portion as map pointing is very simple, guys. I don't want you to point it out in a blank piece of paper like you would do in your class 6th, 7th, or 8th standard and give it to the class teacher that I have finished the homework. No. Here, bring a level of maturity to your preparation. When I give an area for map pointing, I expect something out of you in the sense that I expect you to have the look at where that particular region or portion is situated. Along with that, look at the neighboring and the vicinity portions as well. Get yourself introduced to the world. It is high time in your life that you should be introduced to what the world is. If you are aspiring to become a future decision maker of the country, if you are aspiring to become the future bureaucrat, you cannot come across as a candidate who does not know whether Colombia and Cambodia, they are same or different. Where if Colombia is situated in which particular continent. I'm sure if I ask this question right now, many of you will bungle it up. So I will not take that risk. So I will give you certain portions of map pointing and do point it out on the atlas. Open up the atlas, do look at it where it is situated, and that will be sufficient. Okay. Apirogenic also induce seismic activities in certain cases, yes. Okay. So the portion of map pointing, if I give you, now here again, I expect a basic level of honesty from you guys that at least before coming to the next weekend, have that position or have the idea of where the position is. Atlas, any atlas, okay? Need not be required to have this best kind of atlas in the market. Whatever my friends are reading, I will also need that. Any atlas that you catch hold of, that will be sufficient. So look at few of the mountain chains. So starting with the Appalachian. Where is it situated? Where is Appalachian mountain situated? Good. North America. Rockies. Cascade Ranges. Where are the Cascade Ranges situated? In which portion do we have the Cascade Ranges? Okay, no clue. Okay. Also, North America. Western part of North America. Good. So here, this should be looked into. Then Sierra Madre Oriental, and Occidental, very rich in mineral reserves, also created due to volcanic activities long time back. Where is it situated? Sierra Madre, Oriental and Occidental. Let me see. Good. Again in North America. On both sides of the Mexican plateau, rich in mineral reserves. Okay. So then Brooks Range. Now, this is also situated in North America. Locate these. Then after that, locate Andes. Where are Andes Mountains situated? South America, we have seen repeatedly. Atlas Ranges. Atlas Ranges. Where are Atlas Ranges situated? Let me see if we are aware. It is situated in, very good, Ankit and Himanshu. It is situated in Africa, the northwestern boundary zone of Africa. That is where Atlas Ranges are situated. Then after that, locate Pyrenees. Where are they situated? Where do you find the Pyrenees? Very good, Annie. It is in Europe. Alps, again in Europe. Carpathian, again in Europe. Vosges, again present in Europe, near the region of the Black Forest in Europe. Again, mineral-rich area. Then after that, Ural, again at the boundary region between Europe and Asia. Very good. So all these you will find to be situated in the region of Europe. Okay, all of these. Look at where you find them. Then Drakensberg. Where is Drakensberg situated? Very good. It is South Africa, in the continent of Africa itself. Here also you have the formation of an escarpment. So when you take a look at it, observe the escarpment which is formed in the process as well. Himalayas, I will not give you to map it out because it is very, very easy to map it out. So this is something that I want you to point out in the case of mountain chains. Then after that, look at some of the other landforms. Find out where you have the Ozark Plateau. Colorado Plateau. Beautiful. Okay. Mexican Plateau. Then after that, Mexican Plateau is in between the Sierra Madre Oriental and Occidental, just to give you an idea. Then Altiplano. Altiplano is situated where? Amongst all these, this is the tougher one. Very good, brilliant. It is in South America. right? Yes. Now, these are the areas that you should be looking at. Canadian Shield, etc. I will show it to you eventually. Tibetan Plateau, you should be aware of the stretch of it. Okay. Then after that, you should be aware of, now Sudan is in news. So in Sudan, you have the Darfur region. All these areas you should be aware of. So whenever any portion of current affairs is in news, immediately make it a point that take a look at it, where that place is, and what is the feature of that place. That is something which should be taken a look into. Okay. Then after that, few of the deserts. Rub al Khali. Where is it situated? In which particular area? Good. In the region of Saudi Arabia in Asia, right? Arabian Peninsula in Asia. Then thus they loot. Where is this situated? Very good, Ankit. It is in Iran. This is in Saudi Arabia. Okay. Then after that, look at the Gobi Desert. Again in Asia itself. Look at the Atacama Desert. One of the driest places across the planet. Beautiful. Chile. Then look at the Kalahari Desert. Namib Desert. And Victorian Desert, Great Victorian Desert. Where is the Victorian Desert situated? Very good. Australia. So most of you know all of this, but still what I would want many of you, most of you to be doing is take a look at these areas individually in the atlas. Look at the surrounding regions as well. Don't have the blinkers on that you will only be taking a look at only the portion that where Rockies are, my work is done. Where the Brooks ranges are, my work is done. Look at it beyond what is. So when you are taking a look at the Brooks range, take a point or make a note of where you have Mount Denali, which is the highest peak in North America. When you are taking a look at Andes, try to look at what is the highest peak, Mount Aconcagua. So if you follow this approach, when you are taking a look at Africa, where is Mount Kilimanjaro? If you follow this approach, map pointing will be much more rewarding in general, and it will be an explorative experience for you as well, rather than limiting yourself to a kind of a list which is circulated to you that learn all of this, this is relevant for your examination. That situation should never come in your life, that you are reliant upon a particular list provided by anyone. Even if I provide you that list, you should have a better information than that. Okay, so do look at take a look at this before coming on into the next weekend. Then after that, the exogenic forces that we are going to deal with here. Now, these exogenic forces, they are divided into various different types and categories based upon what these forces are and what is the resultant out of it. So here, basically, when we talk about exogenic forces, these exogenic forces, they can lead to creation of weathering activity. They can lead to mass movement. Mass movement is when large bulk of substances, they move together, large bulk of materials, they move together at one go. That is mass movement. And then you have erosional and depositional activities carried out by various agents of nature, running water, glacial water, groundwater, waves, sea waves and sea currents, as well as the wind movement. So that is basically the exogenic processes that we have. So here we shall be analyzing each one of them. We shall try to understand what each one of them indicate and how they are created. And here basically you have to catch the larger trend. The PPT shall be available to you. Here we shall try to understand it with a kind of a visual perspective. Remember the first session of geography, I had told you that this subject will come to you if you try to imagine it. If you provide that kind of a visual perspective, you will be able to recollect it for a larger duration as well. So that is something that we shall be focusing upon when we take a look at the various different landforms. We start with weathering. Now, what is weathering? Again, a terminology which was initiated in the portion of geography, but now this term is used in your English vocabulary as well. Right? You would have heard about, if you have not heard about, it is oftentimes used in the lingo that continuous posting in the mountains has weathered him down. A repeated preparation of civil services year after year has weathered his personality down. Means what? A kind of a wear and tear of sorts. Now here, what do we mean by weathering when we talk about it in the parlance or in the reference of geography as a subject? So when we have any kind of rock in any place, let's suppose we have a kind of rock. Now this rock will be exposed to various different vagaries of nature. Various different vagaries in the sense that you have the aspect of rainfall happening in that region, sunshine, very significant amount of sunshine, heating for a prolonged duration, nighttime cooling, heating in summer, cooling in winter. Now heating brings about an expansion, cooling brings about a contraction. This rock will have certain minerals which will be soluble in water. So after prolonged exposure to rainfall, those minerals, they will start seeping out, creating gaps in these rocks. In those gaps, slowly and steadily, you will find small rodents and reptiles. They start living there along with multiple insects. That will give rise to few of the plants also in that region. Eventually, you will find that within those rocks, you have the plant growth as well. All of these activities of the nature itself, unadulterated activities, undisturbed activities, eventually leads to the breakage of the rocks. The rocks, they break into smaller parts, the smaller components. And they keep on further continuing to break down until and unless that reduces itself into very small particles that we refer to as soil. So that is the aspect of weathering. So when we say weathering, so breaking down of the rocks by physical, chemical, or biological activity. Now, if the breaking down is happening purely by physical activity means what? Does it mean that the rock has to go on a morning walk and a morning jog in order to break it down? Physical activities of the physical properties of the molecules, the physical properties of the state of matter. If that is compromised, how will that be compromised? So suppose a particular rock is present in a desert area, in the desertified region. Now, if it is present in the desert region, during the daytime, what will be the temperature? Desert areas are very hot during daytime generally. During nighttime, you will find that these desert areas, they are very, very cold. Always you will find that the desert areas are very, very cold during nighttime. So during daytime, the rocks will expand. During nighttime, it will contract. Again, during daytime, it will expand. Again, during nighttime, it will contract. Expansion, contraction, a regular phenomena of expansion and contraction, what will it do? It will weaken the rock structure. And eventually, what will it lead to? The rock will develop cracks. It will break. So that is why, because the physical strength of the rock, the physical bonds of the rocks, they were compromised. And that is the physical weathering. Another example. Suppose this is an area which experiences one of the colder regions of the planet, let's suppose, this experiences rainfall, lot of rainfall. Now let's say due to expansion, contraction, etc., this particular rock has developed a kind of a crack here. Let us assume it has developed a kind of a crack, an extensive crack here. Now here, when you have significant amount of rainfall, water will seep in through these cracks, isn't it? So when the water seeps in through these cracks, it will fill up the entire region with water, wherever the cracks are. Now, during the winter season, this water, I'm talking about the colder areas of the planet, during the winter season, this water will freeze. Now, when the water freezes into ice, I hope we are aware that ice is an expanded form of water, right? Ice will always occupy a larger volume as compared to water. So this ice which will be formed here, it will push the boundary of that crack ever so slightly because it has to expand. What will it lead to? The deepening of the cracks further, expansion of the cracks further. Now the next season or the next year, during the summer conditions, let's say it has melted, this water has melted, there is more addition of water due to rainfall. Again during the winter season, it will again freeze. And again, during that point of time, what will happen? The cracks will further expand. Eventually, this process will continue till the rock breaks itself. So here, by the physical activities of rainfall, heating, cooling, expansion, contraction, if the rocks break down, that is what is physical weathering. Now, what about chemical weathering? So, physical weathering is due to the action, physical action of the rocks in general. So, here you will observe breakage due to actions like heating, cooling, rainfall, expansion, contraction, etc. That is what is physical weathering. Now suppose we have the presence of a rock. Let's suppose we have the presence of a rock here. Now this particular rock type, let us assume, this particular rock type has got materials which are soluble in water. Let's suppose here you have a band of materials. We are going to study about those landforms anyways. So let's assume this is very dominant in calcium. Calcium is soluble in water. I hope we are aware of that. So let's say this is a band made out of calcium. Now in this region, there is significant amount of rainfall which has been happening. Significantly high amount of rainfall has been happening here. Now, this rainwater, very slowly and steadily, it will dissolve the calcium, right? So from here, some portion of that calcium will be dissolved. Let's say for the first 5 years, around 5 centimeter of calcium has been dissolved. And then because eventually that water, it will be oversaturated, it won't be able to dissolve the calcium beyond that. Let's say by actions of evaporation, etc., by actions of various different organisms. For example, when we talk about the ibex species, I hope we have heard about the ibex, the Himalayan tar, and these kinds of mountain goats, the varieties of mountain goats that are present. Now, I hope you have seen the images of them. They climb the vertical walls in a way. They are able to climb the vertical walls of the mountains. And why do they do so? In order to gain access to this calcium, these particular magnesium, and other salts. And these are the nature's original Spider-Man, right? They can climb vertically because of the kind of modification that they have in their hooves, where the hooves, they create a kind of like a suction pump impact, and they can stick. They have a soft hoof with which they can stick themselves to the wall very easily. So that is why you will find them almost in a vertical wall-like structure. They will be very easily be able to climb it up, and they lick these rocks in order to lick away the salts like calcium, magnesium, and so on. Now, thereby, let's suppose these animals come in, they lick away these particular dissolved portion. Slowly and steadily, more amount of it will be dissolved. More amount of it will be dissolved. Eventually, what will happen? After many, many years, the entire portion will be dissolved. The rock will be broken into different pieces, right? But this event has happened. Why? Because of a chemical reaction which has taken place here. That is why this event has happened. So that is chemical weathering, where you have chemical reaction induced by the water soluble materials. Okay, then you have biological weathering. Now, biological weathering is where you will observe that, let's say, the rock has developed a kind of a crack. Let's suppose you have the presence of a rock which has developed a kind of a crack. Let's suppose. Now here, you will observe that an individual small plant will start growing here, having its roots. After, let's say, a couple of seasons, you will find that another plant has started growing here, also having its roots, going across the cracks, trying to extract the minerals, expanding the cracks. Now, if the plants are there, you will find termites, various species of ants, insects, rodents, snakes. They will also come there. They will deepen this crack. They will further deepen this crack. Eventually, it will break. Now, this is something which is initiated by biological events. This is something that you guys would also have come across, something like that. For example, many of the times you would have been to a kind of, let's say, trekking activities, you would have seen that a larger rock structure, a plain rock structure, in the cracks, you have few of the plants growing in those regions. Generally, we don't approach those kinds of cracks because we are very sure that some or the other snake would be living there. Otherwise, also, if you have visited any of the old government buildings, old government housing colonies, which are very, very old, if you look at them, you will be having some amount of doubt that whether this was created pre World War II era or this has been created newly. So very old government buildings. Many of the times you would have observed that even in those government buildings which have not been in habitation for a long period of time, it is lying vacant. You will start observing that from the walls itself, you will have the growth of certain plants, certain shoots will start growing, right? Now that starts to intensify in terms of its growth as well. Slowly and steadily, they will develop a large crack on the wall. And that is when eventually the wall might break also. So that is an example or a characteristic of a pure biological weathering. Out there in the nature, though, it is not classified like this. Out there in the nature, it is oftentimes a resultant of multitude of these processes, where you will find that simultaneously physical, chemical, as well as biological weathering that takes place simultaneously. Right? It is going to be the scenario where, let's say, due to physical weathering, a crack has developed, and that crack has allowed the growth of plants in it. Now, eventually, the plants will also secrete something along with the rainwater. It will start dissolving materials. So, out there in the nature, you'll find a combination of all of the materials or all of these different types of weathering which lead to the breakage of the rocks. Okay? Um, Anand, is physical weathering attributed to natural? All the weathering actions that we have talked about, that is a natural process. When you talk about human caused activities, we humans are enough to cause all the types of events which will break the rocks, pulverize the rocks, but these are natural processes. Now think about it, whether this process will be fast or will this be a slow process? What do you think? When we talk about this weathering, will it be a fast process or will it be a slow process? Beautiful. It will be a very slow and gradual process, very slow. Oftentimes, it can span for thousands of years. And that is how we have the formation of soil. Soil formation is initiated due to the weathering of rocks themselves. If we talk about any particular region where you have the formation or the presence of soil, initially in that area you will only find the presence of rocks. Slowly and steadily, this will weather into much smaller pieces. Right? And that is how even this will be broken into smaller pieces. And that is how eventually this region will have the presence of soil. Still faster than plate tectonic. Yes, that is true. It is still very faster than plate tectonics. Now here, then we come to another exogenic action or exogenic process. That is what is referred to as mass wasting, or what is also referred to as mass movement. This is not like your non-cooperation or civil disobedience movement, that mass movement. Mass movement here basically means that in bulk, the materials, they start to move. Okay, that is what is a mass movement. Always, very important factor for a mass movement to happen is the influence of gravity. Influence of gravity is very essential. Because let's say if the ground surface is like this, absolutely plain, absolutely featureless, on top of it you have a lot of soil, right? Now, regardless of the amount of rainfall, etc., will this end up moving anywhere? No. But if I provide it like this, and the land is like this, and let's say you have a lot of topsoil, loose soil which is present here, in the presence of sufficient amount of rainfall, what will happen? All this soil will drain away. So influence of gravity is very relevant for initiating any kind of mass movement that you come across. It is very, very important for that. Other than that, you have this mass movement which is broadly classified or categorized into slow movement, and fast movement. Okay. So here, let's say, when we talk about slow movement, when will the materials move very slowly? So example of this is like creep. Example, creep. Here, example, slides, landslide, mudslide, earth slide. Then you have falls, rock fall, debris fall, and also you have the various flows, mud flows, earth flows, etc. So when is it that you will have a slow movement? Materials are moving very slowly. When the slope is very gentle, isn't it? Slope is very, very gentle, let's suppose. It doesn't have a lot of gradient associated with it. What can we say about the availability of water? If for a slow movement to happen, the availability of water should be high or should it be low? What do you think? Very good. Very low availability of water, because if the availability of water is high, everything will be drained away very easily. So availability of water is also low. So in the drier areas where you have very little amount of water and the gradient is also very less, you will come across the slow movement. Very, very significantly slow movement. On the other hand, whenever you come across a fast movement, what is a fast movement? So fast movement here will always have a significant amount of slope associated. Water availability will be high. That is when materials will start falling off left, right, and center. Right? So that is how the categorization is done. Now here, this entire mass movement depends upon the volume of material, the volume which can actually flow, the volume which can actually move. Okay? Volume which can actually move. Water content as well. If the water content is high, movement will also be higher. If the water content is lower, the movement, the rate of movement associated will also be much lower. Slope steepness is very important. If the slope, let's say, is like this, regardless of whether it is dry or not, it will always lead to falling of it. Or if it is too much water, less water, any material which is loose here, lying here, it will immediately fall here. Okay? That is the basic aspect. In all these aspects, gravity is a must. Okay? Now, let me ask a question out of it. So, when we say with regards to mass movement, consider the role played by weathering. A. Absolutely essential for mass wasting to happen. B. Increases or facilitates mass wasting. C. Has got no role to play in mass wasting. Okay? And D. Decreases the outflow of materials during mass wasting. So, what is the role played by weathering in the case of mass wasting? This is where many of the times questions have been asked which tricks the candidates left, right, and center. And if weathering is something which simply helps the process of mass wasting, or is it something which is absolutely essential for the mass wasting to happen? Good. I can see the confusion lying here as well. So basically, it simply increases or facilitates mass wasting. It is not essential for mass wasting to absolutely happen. It simply augments or facilitates it. Keep that in mind. The force which is, or the event which is absolutely relevant, absolutely important for mass wasting is gravitational force. Rest all of them is a mere addendum in the process. This is absolute must. Absolute must. Okay. Now we come to some of the types of mass wasting. For example, landslides. This is again a kind of a fast moving and a fast mass wasting. And then we have, let's say, creep. And then this is your solifluction. So in the case of landslides, you would have observed that here materials, they start flowing down the slope. When will they flow down the slope? They will be flowing when there is a gradient, when there is a steepness associated, right? So in the cases of steep slope, what about the volume of material? If, let's say, in a particular hilly area, if you have a lot of trees, deep rooted trees, not the eucalyptus ones, if you have lot of trees, will there be landslide experienced in this area or not? Very dense vegetation. No. Good. Because it will bind the soil. So here you need availability of loose soil and rocks and boulders. Then what about the availability of water? Sufficient and high water requirement, high water availability. Whenever these conditions are fulfilled, it will lead to the creation and formation of landslides. We will talk about landslides. I will give you the written portion of it as well. Okay, so that leads to landslides. What about creep? So creep basically is a very slow process. Very slow process. So many of the times you would have observed, if you are living in an area which doesn't have a very apparent slope in that region, generally all the regions have some or the other kind of a slope. In order to gain an idea about what is the slope in your land, just observe where the rainwater goes. That will give you an idea about in which direction the land is sloped. So in many of the areas, you would have come across the fact that all the telephone poles, they are bent in the same direction, right? They are gently bent in the same direction. Sometimes even the older boundary walls, they also have a bend in the same direction. I'm not talking about those telephone poles which are like this. I'm not talking about those telephone poles which have almost fallen on the ground. That is because of purely poor maintenance on the side of Sarkare Hind or the government that is present in that region. So that is purely because of that. I'm talking about the slow and gentle slope. That is what is creep. So creep is observed when you have a very gentle slope, an absolute lack of availability of water, and very little amount of water. And there is a gentle slope, so lesser movement is observed. Many of the times, even the trees, they indicate a bend in a certain direction. So that is what is a creep. Okay? Now, then you have a very interesting one, that is solifluction. Now here, observe the image first of all. In this image, you will observe there's a kind of a flow associated. I hope you are able to take a note of this. There is a kind of a flow associated here. It appears as if the soil in itself is flowing like a liquid, hence the name solifluction. So this is observed across areas of permafrost. Permafrost means the region which is permanently frozen. Observed across permafrost, where even during the summer season, the topsoil is something which gets free from ice, but the lower region, the lower subsoil is permanently frozen. So this is permanently frozen. So in these areas, during the summer months, the topsoil becomes ice free. During summer, topsoil becomes ice free. Okay. Now, the bottom soil is still frozen. Okay, so we are talking about the high latitude regions. For example, northernmost part of Europe, northernmost part of North America, northernmost areas of Siberia, regions of Greenland, those areas, which are almost permanently frozen. For a couple of months, the topsoil will be free of ice, and then the bottom soil is still frozen. So in that case, the top soil and the bottom soil, they don't have that kind of a connect or contact anymore. They are free to move over each other. And then as the ice is melting, even in the case of the topsoil, that will provide the lubrication, due to which the topsoil starts generating or flowing like a fluidic substance. That is what is solifluction. So observed in very high altitudes and very high latitudes. Observed in very high altitudes and high latitudes. Okay. Now, here, a landslide is defined as a movement of a mass of rock, debris, or earth down a slope. It can be initiated in slopes already on the verge of movement by rainfall, snow melt, changes in the water level in the case of rivers, stream erosion carried on by the rivers, changes in groundwater, even earthquakes can lead to landslides, volcanic activity, disturbance by human activity as well. Wherever we have seen that nature is doing its bit, we have that FOMO feeling. So we also have the power to create landslides or combination of any of these factors. Earthquake shaking and other factors can induce landslides underwater as well. And these are referred to as submarine landslides. So from here, an MCQ can be framed. Landslides are observed only over the terrestrial regions. Majority of us will mark it as correct, but it is incorrect. Okay. Now, after that, we come at the process of gradation. Gradation means what? It means leveling. Something which is leveling, right? That is what is referred to as gradation. Okay. So that is a continuous leveling process. That is why it is said always that the endogenic forces, they are the builders. The exogenic forces are the levelers. Why? Because the endogenic forces, they put in a lot of effort to build the continents, to build the mountains, to build the plateaus. And the exogenic forces, though, they know only one thing: to level it off, to shave it off. At one point of time, I don't know if we are aware of this or not. At one point of time, it is said that Aravali hills that we have, the Aravali ranges that we have, these were one of the tallest mountains of the world. You had multiple peaks in that area which were completely covered in snow and ice throughout the year. You had massive glaciers which would originate from the region of the Aravalis. What you see in the case of Himalayas today, imagine Aravalis were at one point of time very similar to that. The moment the endogenic forces stopped acting, look at what the exogenic forces have done to the Aravalis. It is like one of those who is still trying to find its own identity because everything has been eroded. Now they are no longer regarded as mountains also. They are regarded as hills, and not even hills, relict or residual hills. Many of the portions have been taken away by erosion, by weathering. So that is because of gradation. It is a consistent process. Any area which is elevated, it will be eroded. It will be weathered down. Materials will be carried somewhere in order to attain a kind of a stability. So suppose you have a landmass. Let's suppose you have a landmass like this. Now here, if you have a kind of an uphill portion, right? Generally, you will observe that materials will be eroded from here. They will be carried over a distance, and wherever there is a depression or a low-lying area, the materials will be deposited in that area. So the entire process of leveling is not only about removing any kind of protrusion, it is also the deposition of it. That is basically the leveling. So gradation involves three processes: degradation, that is erosion; transportation; and aggradation. They are carried out by various agents of nature: running water, underground water, one of the most powerful and most significant agent of nature, glacier, as well as wind and the sea waves. So we'll take a look at all of them. Okay. So a couple of questions I'll take. Abhishek, we studied in geography that land is formed due to weathering of mountains. Land is formed due to weathering of mountains emerged by volcanic eruption. This postulation in itself is incorrect, Abhishek. Land is not always formed due to weathering. It can be a volcanic island as well. Soil is formed as a result of that. So in case of northern Indian plains, there is soil in abundance. So whether weathering happened fast here or volcanic mountains are older in northern plains. Northern plains does not have volcanic mountains at all. Northern plains are created as a result of pure deposition. We'll come to it. There is a kind of a theory about that as well, which was provided by Edward Seuss. Now, that talks about the creation of a shallow sea. As the Himalayas were forming, before that, you had, or in front of that, you had a creation of a depression where waters of Ganga, Indus, and Brahmaputra, they drained into that region, formed shallow sea, and they created all that deposit. And that is the deposit that we have in the form of northern plains. Okay? We'll come to it in Indian geography. Sakshi, that's why Indian culture is different from the rest of the world. Aravalli Hills separate India. Okay. And I read somewhere that Sahara Desert used to be a sea or ocean. Is it the same in the case of Thar Desert? Sahara Desert was not a sea. Northern portion of it was underwater. Sahara Desert at one point of time around 14,000 years back, 14 to 20,000 years back, it was forested. It had very lush green forests. It is the continental shift which has happened, and also the climatic impact which has occurred that has created a kind of a desert. Few million years back, if you look into it, Sahara was not a desert. About Thar, when you talk about the Thar Desert was underwater. And yesterday also we talked about that when we're talking about formation of Himalayas. As you had the Indian plate moving northwards, as the Tethys Sea and Tethyan Sea floor was getting compressed from both sides, water entered into the region of the present day Western Rajasthan, and that is where you had a shallow sea created. That is why the region of Thar and the northern portion, the Shekhawati region of Rajasthan, for example, that is very significantly rich in fossil fuels, crude oil, natural gas, as well as you will find the presence of limestone. Limestone always indicates a kind of a marine existence at some point of time or the other. Okay? So How underground water causes gradation? We'll come to it. Mostly it is by the chemical process. Chemical process of dissolution of materials soluble in water. In water. It is not purely the underground water which has an impact, but many of the times surface water which also has an impact in the underground region. So that also leads to it. So now we take a break, your snack break, and we take a 30 minutes break. So we come back at 5:35 p.m. sharp. Okay. Okay. So see you at 5:35 p.m. again. I hope you are active enough by that point of time. Okay.